Hello and welcome to the Weaveworks webinar. This is our September launch event. So let's get started. So we're using Zoom and this session is being recorded. There will be a Q&A session at the end. So if you have any questions during the presentations and the demos, please type your questions into the Q&A section of Zoom and we'll get to those at the end. So before we start with what's new, just a quick recap on Weave GitOps. It's a GitOps platform for managing your Kubernetes clusters, be they in the cloud, in the data center, or at the edge, and the applications and services that run on those. It's built on a solid foundation of Flux, and with the enhancements that Weave GitOps puts on top of Flux, it's going to enhance the security and accelerate your software delivery lifecycle. So what's new in this release? We have team workspaces or multi-tenancy. We have exciting news around trusted delivery, policy as code. And we have a sneak peek, a technology preview of GitOps Run. This should be GA shortly after this event. And then finally, progressive delivery. So we're sort of going through from like the platform or the operator side of things, setting up the workspaces and the policy as code, and then going to the developer personality with GitOps Run, which is much more of a dev tool, and progressive delivery, again, more along the developer side of things. So let's get started on the first one, team workspaces. So in an enterprise, you're going to have a number of clusters, and on those clusters, there's going to be a number of applications and services running, and there's going to be a bunch of DevOps teams looking after all of that. So how do you get everybody to play together nicely and not step on each other's toes, as well as, of course, having that security aspect? Well, the answer is Teams Workspaces. So it enables multiple DevOps teams to work seamlessly together, so using both policies and roles-based access control. We ensure that different teams only have access to what they should have access to from the security point of view. But also, if you don't have access to something, then you're not going to see it. So that allows you to focus in on what your area of concern is. So for example, if I'm a developer and I'm working on the payment gateway, I don't really want to sort of see all the other services and everything else that's going on. I just want to be able to focus on what I'm working on. And as I say, also there's the protection in there as well. So this is going to say stop a junior developer accidentally deploying something into production, because they wouldn't have the permission to do so. How it works, there's a YAML file that defines the workspace, and that is processed by Weave GitOps, and it then creates all the other entities that make that happen. So like the role binding, the policies that enforce that, and any namespaces associated with those workspaces. So it all happens automatically for you. You only have to worry about managing and maintaining one relatively small and simple YAML file, and all that complexity is abstracted away from you. So typically a platform team will be setting up the workspaces, and it's built on top of Flux's tenancy model, which is a bit of an industry standard. As we said, it allows teams to work nicely together, and also an ease of use in that it's going to focus teams in on just the things that they're interested in. So without any more, we should have a live demo now. So I will hand over and we should see it in action.
Hey, good evening, everybody. My name is David Stauffer, and I'm a PM here at Weaveworks. And I am going to show you today really how a platform team will onboard the application teams, which we learned from our customers is one of the biggest tasks. So what you see here is a single pane of glass, and what you will notice that I'm logged in as the platform team, as one of the admins, and you will see that the single pane of glass gives me literally everything. In this environment, we have over a fleet over 13 clusters already connected to us. We have our templates. We have basically everything in one place. We have our applications.
Sorry, David. You're not sharing.
Yes.
Sorry.
Oh, sorry. I forgot the right button. Okay, so again, this is our single pane of glass, and as you can see, I have here in our UI everything. You can see that I'm logged in as one of the admins. I'm one of the part of the platform operator team, and I have basically here everything. My cluster estate, my fleet of 13 clusters. I have here all the stuff which is deployed across this fleet of clusters. And today we will really focus on our cluster demo 28 we just brought up. And as you can see, we have brought up all the machinery, but now we really need to start to worry how we can enable our platform, our application team. So what we will do is we will show you how you can create declaratively in a GitOps way a tenant. And how this works is that you can see that I have here my tenants.yaml. This is my declaration. And I want to create want to help our team super devs. And so what we're going to create for them is a namespace we call super devs. And we're going to say what kind of Git repositories are allowed sources for them. Because if you really do GitOps to a degree, your problem shifts a bit left, because now the point of entry is your Git repository. So we want to tie this down. And what this does is it will create automatically the correct policies for you. As well, we're going to define some, in this example, some team RBAC, and we're going to say, what is this team allowed to do if I am part of, this is actually the product management team of Weaveworks, and my colleague is going to show how it will look for him when he's going to use this tenant. So what we're going to do next is we have already installed our command line tool, and we're going to run our GitOps create tenant command. Let me one sec. I just want to copy it clean. I'm going to copy and paste this. What we're going to do is we're going to say create a tenant. From the file, we're going to use the tenants file and export it to our repository that we use for our management cluster. So this is done. Let's see what happened. If we go now to a different screen, which is our demo 28 repository, we can see that we created all these new files. So we can see that we have specified here the namespace. We say what service account we want to use. We default, if you specify nothing, to the Flux one. We have here our role binding. We have here our roles, and we have here our policies. But this is not everything we need to do, because the second step we need to do is we need to create a second file for them, which is basically the repositories they want to use. And they want to use basically this repository. We have coordinated with the team, and we're gonna create this as well directly for them. A typical task of what we see by day by our platform teams. So we can see that we created as well this source. And now this is GitOps. What I'm going to do is I'm going to create a new branch. I'm going to call this we add tenant super dev and source. And we're going to commit those changes. Oh, I did forget a message. Let's see, maybe it breaks. Come on. Let's see how quickly VS Code recovers. My 1 second, that's a board. Yes. Come on. Git commit, we can as well do it manually. Okay. And now we're gonna do a git push. We're gonna set up the stream. Yes. And we should now, if we go to our Git repository, see this pull request. So let's create the pull request. Let's see again what we're going to merge. And it's A, the source we need for our application team, and B, it's all the tenancy files. So what we're going to do is I'm going to approve this myself and merge the pull request. And we don't need any more the branch. We're going to clean this up. And I'm going to do quickly poke Flux system to sync the change already in so that we get what we need into the cluster. So let's give this a second, and we should see in a second that our tenant comes alive. And we will have a couple of proof points for this. So in our UI, things will change. So if we go now to policies, we should see that we have now policies attached to our tenant superdev. And this is, for example, forget the management cluster, focus on the demo 28 cluster. And these are just the policies we added. So we defined what clusters they are allowed to deploy to and what are the allowed repositories. The same we can see for our sources if we go to our sources. And if we filter this down by our demo 28, we should see the new source we just created. Where is it? Oh, the source is not yet there. Let's give it a moment. Let's double check what I merged. No, the source is there. It's in the right namespace. It should be there. So I think at this point, I can already hand over back to you, Steve, because we have done the groundwork that we can use this tenant.
Okay, excellent demo, although VS Code gave you a small heart attack there. So let's move on from teams to trusted delivery. So the problem is we want to give our engineers freedom so that they can ship new features and fixes quickly. But we don't want to give them total freedom because people make typos, people maybe don't follow policy, so we want to keep them in check. So it's this balance of giving them enough freedom to go quickly, but also keeping control and making sure standards are adhered to. So this is really where policy as code comes in that you can give the developers freedom, but with the automatic checking of policy as code, we can make sure that those standards are adhered to. And it also is going to speed things up because of the automatic checking with policy as code, we don't need to do as much manual checking. So we don't have that bottleneck of things queuing up, waiting for a manual review and approval. So policies code is going to work on in a number of areas. So we make sure, first of all, things are properly configured. So this is really sort of around the resilience of an application. So do we have consistent labels? Do we have suitable graphic account and resource quotas? All those types of things. And again, it might not be that the developers are deliberately missing this stuff. Everybody makes a typing mistake, and a label mistyped doesn't exist. So we want to make sure that everything's done properly. Then we got the security angle there. So we want to make sure that we're maybe only using images from a trusted image repository and not just randomly pulling stuff off Docker Hub or from wherever else. And also then around vulnerable configurations, so things like runners, root, or privileged containers, those types of things, maybe we don't want to allow those in certain areas. And we want to follow industry standards and best practices, so things like PCI DSS, HIPAA, etc. So yeah, the policy as code is going to focus around security, resilience, and coding standards. And by checking early, we're going to shift left that capability. And we can check at multiple points throughout the software delivery lifecycle. So using GitHub Actions, for example, we could check at the time of a pull request. So we just saw David do a pull request. We could actually have policy as code validate that at that pull request. So when someone goes to review that pull request, straight away they can see there are policy violations. Within that loop, we can also do automatic remediation for certain use cases anyway. So take a simple one like replica count for a container. We might say, well, we're deploying into production, therefore we need a replica count as a bare minimum of 3. And maybe a bit of mistyping and the manifest only has 1, then it's quite easy to programmatically change that 1 to a 3 and create a PR against that change. So we can do a certain amount of automatic remediation. And because we can automate a lot of those checks and some of the remediation, then that's really going to speed things up, because we're not getting bottlenecked on those manual reviews and approves. The solution comes with a library of over 100 policies covering those various industry standards, such as PCI and SOP2. So that's enough of me. Time for another live demo. So I will hand over.
All right. Thanks, Steve. Just sharing my screen. All right. So hello, everyone. I'm Mustafa Migahid. I'm a PM in Weaveworks, and I'm going to show you some demos and showcase the policy as code and what it does. So as Steve was saying, we have over 100 policies that cover security, operational, and industry standards. And you can actually manage all of these in Git, because they live in Git. You can actually manage them, configure them, and create your own new custom policies that comply with your organizational standards. So as you can see, this is the library of policies that we provide from Weaveworks, and you create your own. So once you have the policies in there, so as a platform operator, you have 3 modes to enforce these policies, basically. The first mode is the commit time validation. So basically what I want to do is shift left the security and enable my team to actually, the application developers, to actually check on the policy violations early in the process instead of waiting to deploy and get blocked. So they have the violation report in Git so they can know what to fix. So what you're seeing here is an example violation report that lives in GitHub, telling which policies are being violated, how many violations, and basically we have also the auto remediation one that helps developers fix it. So that's mode number 1. The other mode is the audit mode. So basically you have like 20 policies, even 100 policies that you want to audit your infrastructure against. So basically the audit mode will have a dry run on these policies on all of your clusters and publish the violations in JSON format. So you can actually use this and compile them into dashboards, or actually use one of the built-in dashboards that we built in Weaveworks, like this one I'm showing here. So here you can see how many policies are being evaluated on your infrastructure and how many are violated right now, how many total violations, that's multiplication of objects being violated versus the policies. And also you can see, okay, so what's my top violating policy in my infrastructure? So I want to focus on that. So you can see what is the policies that's top violated. And also you can see an overview of your benchmark violations, and you see how your infrastructure is complying against defined and popular benchmarks like the CIS benchmark, GDPR, PCI DSS, and other benchmarks. So that's the second mode. So the third mode, and the most important one, is the deploy time enforcement. So basically what you have is you want to enforce a policy and make sure that no violating change for this policy will get into your cluster. And that's basically the demo I'm going to show you right now. So if we go here, I have a policy that enforce container minimum replica count. And we want to make that work actually with the tenancy work that David showed us earlier. So not only is that I want to enforce that into the cluster, I want to enforce it into the on the deployments that the team super devs is actually working on. So here, as you can see, I can define the tenants that I'm targeting, and also I can define the namespace super dev, which any deployment this team will go into. So as you can see here, I want to enforce a minimum replica count of 2. The parameter here, which is configured, you can actually change it however you like without touching the Rego code. That's actually, we provide most of the Rego code in the policy libraries that we have. All right, so let me actually add this policy right now. So I have it here. So we have a customization, and if you're noticing on the policy views that I showed you earlier, we already had these policies installed in the cluster. They are running in the audit mode. And we added this policy, the tenant policy that we want to enforce. And in order to enforce that, we are using a custom resource called a policy set. So if we go to the policy set here, we are saying, okay, we want to enforce anything related to tenancy. And so any policies related to tenancy will be enforced into that cluster. So let's actually commit that change right now. Right. Let's see, we have some updates. Right, and push that directly to the cluster. What will happen is this policy will get reconciled and should show in our policies here. Just give it a second. Right, there we have it. So anything that super devs team will try, any deployments that they will try to deploy that has a minimum, a replica count less than 2 will get blocked. And you can see here that it's targeting the tenant super devs. And yeah, that's basically it. So you set the policy, now it's the turn for the app developer to actually try and have their deployments. Now back to Steve.
Okay, thank you, Mustafa. I will share my screen again. So we've seen the platform team set up the team workspaces, and the platform team has also then tweaked some policies around that. So enhanced some policies, added a custom policy on top of some existing policies from our curated library. So now we're having a little bit of a personality change, and we're going away from the operator and platform side to the developer side. And we're going to take a look at GitOps Run, which is a technology preview currently. So what is GitOps Run? So it's going to allow you to very quickly get a cluster, get your existing cluster, get Weave GitOps installed on that, and get that up and running. But also then it's really that main use case around being able to rapidly iterate the changes. So if you've seen in the regular GitOps way, we make a change, we commit it, we push it, and we push directly, or we might have to go via a PR depending on Git permissions. So that all takes a little while. And if you're just in development or you're troubleshooting something, you want to be able to quickly go through a whole load of what ifs. What if I just change this? Does that improve things? You want to be able to do that pretty quickly. And this is the use case where GitOps Run really shines. So it's a bit like kubectl port forward in that you run it in the background and it does some magic. So what it's going to do is going to keep an eye on the changes in your local file system, and it's going to connect to the Kubernetes cluster that's in your current kube config. So when you make a change to a file locally and save that change, GitOps Run detects that and does the reconciliation almost immediately. So you can very quickly try out a config change and see if it worked. And then once you've done that and you've got a configuration that you think you're happy with and you want to make permanent, and you can stop GitOps Run and do your regular commit and push as you would do. And then you've got all that version history and an audit trail in Git and the regular Git continuous reconciliation happening. So really, it's a great tool for sort of dev and test type environments where you're just wanting to quickly mess around, try a few things out, see what works, what doesn't work. And then when you're happy, you can stop GitOps Run and use the regular full GitOps with all that version control and audit history. So quick little utility, and time for a demo to see it in action.
Right, hello everyone. So I am another David, and I'm another product manager here at Weaveworks, but today I am going to masquerade as SuperDev, and I will be showing you to start with GitOps Run, which, as we've mentioned, is a new technology preview feature, which is designed around really helping the application operator have a fast and responsive inner loop for their deployments on Kubernetes. This is a fast evolving feature. We really do value your feedback. So there's a few ways that you can provide that for us. You can join our beta program, which we can provide you details on, or because this is part of our Weave GitOps open source project, you can hop into the community, join our Slack channel, jump into GitHub issues, let us know what works for you, what doesn't, what new features you'd like to see. As I say, we really would value this feedback, so please give it a go. So in terms of a demo, so let me share my screen to start with. So you should now be seeing a terminal. Hopefully this is just about large enough for folks. Make it a wee bit bigger. All right, so I have a local Kubernetes cluster running with nothing. This is just a kind cluster at the moment. So I do get pods. There's nothing really there. I'm going to create a new directory to do some development in. So let's call that webinar demo. And then I'm going to clone an application repository from GitHub. So this is my application repo. Contains very simple application. This is for a production deployment. So this includes a canary, which is something that we'll talk about later when we do the progressive delivery demo. Includes standard deployment, horizontal pod autoscaler, an ingress and customization to apply all of these. As I say, that's for a production cluster. So assuming this would be for more development, trying out changes, I'm going to switch branch to something that matches that kind of environment. So if I check out, actually, cdn check out dev. If I do another tree, then this is an even more stripped down version where it just has the deployment, the horizontal pod autoscaler, and now a namespace to create that locally. So now I can use GitOps run. So if I do GitOps beta run, and then I provide it a path within this repository, or my manifests are under this pod info directory. What this is now doing is it's querying my local Kubernetes cluster, and it's trying to determine if Flux is already there. In this case, it's not. As I say, this is a brand new, fresh cluster. And what it will do for me is it will install Flux using the latest available version. So as an application operator, this is completely transparent to me. I don't need to worry about using Flux or any kind of Flux commands to have locally. This can take anything between 30 seconds to a couple of minutes based on your network. It's installed quite quickly for me, which is nice. Once that's all ready, we take another look at what's happened. We should now see some pods in the Flux system namespace, so I can verify that Flux is running. It's prompting me, do I want to install the GitOps dashboard? So that same UI that you saw David and Mustafa show, that is our enterprise offering. We also have a free open source offering, and that's what it's asking me to install now. So if I say yes, it will generate a cluster user for me using the admin name. I can provide a password, something secure like password, and then it will create that Helm release to install the Weave GitOps dashboard for me and configure it appropriately. So if I jump back into this tab, we should see another controller coming up, which is the Weave GitOps dashboard. We'll wait for that to complete. So now what it is doing is it is creating a bucket on the cluster, which will then all of my local files, so that directory that I suggested it would take /podinfo, that is now being mapped into the dev bucket. Flux is using that as a source, and it is deploying that continuously to my cluster. So I had a namespace called superdevs. So just to see how things are getting on, let's have a look at the namespaces, and superdevs is there. Great. So let's jump into VS Code. And again, I'll make this a little bit bigger. Hopefully that's just about reasonable. We'll create a new terminal, and let's keep an eye on what's going on in that superdevs namespace. So if I do get pods -name space superdevs, we'll put a watch on that so we can see any changes. I've currently got my pod info deployment as defined over here running. So as we've seen the kind of like standard GitOps development lifecycle, you create your change, you commit it, you push it, you make a PR, that gets reviewed, the review merges, that then kicks off a reconciliation loop, and it gets deployed on the cluster, which can take a little bit of time. So when you're just wanting to quickly dive in, diagnose some problems perhaps, or just try out a few changes, see what works before you jump back into that cycle, GitOps Run is designed to give you that fast, iterative inner loop. So for example, I'm going to do a very simple change just to show this. I'm going to bump the replica count. So instead of having one container, I have two. So in this case, because I'm using a pod autoscaler or horizontal pod autoscaler, I can do so here. Currently it's on 1 and 1. I'm going to change it to 2 and 2. And as soon as I press save, what we should see is, there we go. So GitOps Run has noticed that there's been a change in my local file system. It's pushed that change to the bucket. Flux has recognized the change in the bucket, and it has applied that already on my cluster. So it's a much, much faster experience for you trying to create and change things. So I now have 2 different pods running for pod info. Once I'm done, once I'm happy, then I can hop back into my terminal, which was running GitOps Run. I can kill that process, and that's going to remove the dev bucket. It's going to remove the customization, and it's going to get my cluster back into the state beforehand, only now with Flux installed for me. If we go back into VS Code, as I say, we can get ready for checking this back into Git. I can say update HPA, stage my change, commit that to the dev branch, and synchronize my changes. And there we have it. We're back into full GitOps mode. So I'd say this is a very simple demo, but hopefully that gives you a taste of how the developer experience can be. As I say, really do welcome your feedback on this feature, and hope you enjoy it. Back to you, Steve.
So progressive delivery, we all know that the best way to get any piece of software to break is deploy it into production. You know, it works fine in test and staging. We put it into production and it breaks. So how do we mitigate that risk? You know, we want to get, obviously we want to get stuff into production, but we need to be able to do that in a safe way. We don't want to throw it into production, have it break, and upset all our customers. So this is really where progressive delivery comes about. There's various strategies for doing it, but essentially they all pretty much boil down to the same idea, in that we have our existing release which is running, and we have a new release we'd really like to get out there. And rather than just give the new release to everybody, what we do is we give the new release to a small percentage of requests, and then we monitor how that's working using service level objectives with data from common observability tools such as Prometheus, Datadog, New Relic. And as long as we're still hitting the SLO on that new release, we gradually increase the amount of traffic that that new release gets until we hit a threshold where we say, okay, actually we're happy, it's still behaving itself, and then we do that 100%, everybody gets the new release. Because if the SLO analysis fails at any point, we then have the option to roll back to that original release. And in that case, only a small percentage of our customers have been affected by that problem. So it's a much safer way of getting new features and fixes into our production environment. We can do it quickly, but we can do it safely. So we now have progressive delivery inside Weave GitOps. Many DevOps teams are a little hesitant to use progressive delivery techniques because of the perceived complexity. You're talking about managing service meshes and ingress controllers and lots of really horrible, hairy configuration. Don't go there. So what we do is we abstract all that complexity away into one simple configuration file, which we had a brief glimpse of in David's demo there, that canary file. I'm sure we'll come back to that in more detail. So that defines our rollout, what technique we're going to use to roll out, what the SLOs are, where we're getting the metrics from. All of that is defined in a simple configuration file. And then when that gets deployed, everything else then happens as a result of that. And everything is entirely automated. And you can get notifications. So as that automation happens and your progressive delivery progresses out, you will get a notification as it goes through each step. Or if there is a problem and it has to roll back again, you can have a notification coming back from that. So you're always informed as to what's happening. And also you get live update on the Weave GitOps dashboard. So back to you, David.
Right, so hello again. So now I'm going to do a bit of personality switch, and I'm going to hop back into a platform operator role for this progressive delivery demo. So first off, to enable progressive delivery, we are going to install Flagger on our cluster. So to do so, as an administrator, I can come in, I can add a new application to demo 28, which is the cluster that we are using. I can pull from our profile library. So these are curated Helm charts from Weaveworks, which we verified to work. And they can be really useful when you're just trying to like bootstrap your own paths with common componentry as you're doing cluster bootstrap, or even as I'm showing now, post creation, adding some common components to your cluster. So for progressive delivery, I am going to install Flagger, and I'm going to do so in the Flagger namespace, taking default values, which will ask Flagger to install its own version of Prometheus and to install a load tester, which we can use during the analysis phase of a progressive delivery rollout to verify that our new version of an application is performing as we would expect it to. So I'm just going to authenticate with GitHub and do that in this browser. That will do. Too many tabs as always. Authorize, then go back to, yeah. So I can now create pull request. And follow the pull request. It's forgotten that I'm here. So what we'll do is we'll go to the cluster repo. Should see a new pull request. Make that a bit bigger so folks can see it. And what it's doing here is it's adding a new Helm release, which is going to install Flagger. So assuming we are okay with that, we're going to merge the PR. And then I can hop back into my administrator view, just to poke Flux system as we've been doing to make sure that things reconcile quickly. So here we are, Flux system. I'm just going to kick off a reconciliation. So that is now reconciling. It's applied a new commit. And then we should start to see Flagger. So if we have a look at Flagger, this is obviously very new. It's only just starting to deploy now, but it will deploy some things in the Flagger namespace. So we have Flagger itself, we have the load tester, and we have Prometheus. So now I'm going to hop into a different view as the application operator. So let's do that. So instead of logging in as an administrator, I'm going to log in using our ORDC integration. So this is my limited SuperDevs user, and I can try to add another application, but this will be for an app called PodInfo. So this time I can only see the cluster which I have permitted access for. I can only see the sources that I have access for. So this is what David set up for me already. And I'm going to call it PodInfo, put it in SuperDevs namespace. And I'm going to give it a path of PodInfo. So it's the same application that I did in the GitOps run demo. Because I'm in a different browser, I need to do this again. So let's just authenticate. Wait for that to complete. There we go. Create a new PR. So that's created the pull request on my cluster repo. This time it is adding a customization, which is pointing to the Git repository SuperDevs apps, and it's going to apply everything under the /podinfo folder. So let's merge that. And we should be able to reconcile it just with my OIDC one. Actually, no, because it's a new one, I'd need the admin. So let's go to the admin view, go back to Flux system, poke that again so that it realizes that there is another application being deployed. If I hop into my my superdevs user, I can see that it has applied it, but it's not succeeded. If we look into the details for this, we can see that it's failed a policy check. So the replica count must be greater than or equal to 2, and it's found 1. So if I hop into superdevs apps, and then that should give me the URL. It's having a bit of a wobbly, we'll go there. So I can hop into this one. I can indeed verify that my HPA is on 1 and 1. I remember what you're thinking. We've already fixed this, haven't we? And you are entirely correct. So we can do a pull request to update the HPA from dev to main. Let's do that now. Updating the HPA to have 2 replicas, so now it will pass that policy. Go to merge, delete my branch. No longer need that for purposes of this demo. And it has now reconciled successfully. Didn't even need to poke it. So if I hop back into the administrator view, I'm now going to show you progressive delivery in full. So if we hop into delivery, so this, as an administrator, this is pulling across every single cluster that we have connected, and this will give you your single pane of glass for all of your deployments, which are trying to make use of Flagger for progressive delivery. So as we can see, we have this new pod info canary that is defined. It's on demo 28 in the namespace superdevs. It's targeting the pod info deployment. And it has currently deployed 6.1.0 of my application. If we look into the details for this particular canary, then we get a lot more information. You can see basic status. You can see the reconciled objects that have been created. So I'll walk you through how Flagger does this. When you create a deployment, what Flagger will do is it will create copies of that. So you'll end up with what's called a canary deployment and a primary deployment. So the primary serves your main traffic, whereas the canary is used to perform analysis against. And when you're using a canary release strategy, what Flagger will do is it will scale up a new version and it will incrementally shift traffic towards that new deployment. So you can then run your various performance tests against it to make sure that it does indeed meet your expectations. And it gives you that final safety net before actually going live into production. And crucially, if it fails, then you've still got that primary there. That's still serving the majority of your traffic. And it will just roll back the attempted canary. So you've minimized your blast radius through that. You get a series of events, so you can see everything that is happening in almost real time. You can see how this particular rollout has been defined to be measured. So this is using a request success rate. And we can see the YAML configuration for the canary itself. So I'll just make that a little bit bigger so you can see, and we'll look at some key details. So I should point out for this, we're using Nginx. Flagger works, it's very flexible, can be used with Linkerd, can be used with Istio, traffic, whatever your preferred technology is, and that makes it really nice to integrate with what you already have. But it doesn't need a service mesh. It can work entirely with something as simple as an Nginx ingress, which is what this one is using. So if we scroll down, I can walk you through how this one is configured. So basically what we are saying is we are going to gradually increase traffic up to a maximum of 45% in increments of 15. So this will do 3 iterations essentially. And that will happen every 30 seconds whilst checking the request success rate. During that time, it's going to use the integrated load tester to make sure that there is traffic hitting that canary so that we can do said analysis. We'll see that happen in a moment. So to do so, I'm going to trigger a new deployment. So if I hop back into my application repo, then I'm going to bump my deployment. Instead of being at 6.1.0, it's going to be at 6.2.0. I will commit to main. It's done. I will sync this customization so it gets the new version deployed. So that's now deploying the latest commit. And again, in this view, we can see that a new revision has been detected. So what we should start to see here, zoom out slightly so you can see, the base deployment that I had created has now been updated to 6.2.0, and that's going to scale up. Once it's scaled up, then Flagger will start to route some traffic towards it. We can start to see that happening. So if we look in the events, we can see that 15% traffic has been shifted. Tests are going okay so far. No failed checks. We can see that it is progressing successfully. As I say, so this will do 3 iterations. So this will take roughly 1.5 minutes for it to succeed and fail, or fail, I should say. Can't do both. We can keep an eye on how it's going. Hopefully that's not an issue. We shall find out in a bit. Just choosing Flagger load tester in the Flagger namespace. Should be correct. Oh, it's going to be close. We'll just wait for this another 30 seconds and see whether it succeeds or fails. It's looking like it should be okay. So this will do one final check, decide whether it is successful or not. And it has been successful. So now it is going to promote. So what we are seeing is that primary deployment, which had been on 6.1.0, has now been updated to 6.2.0. Canary is still there, still with 2 replicas, whilst the primary now updates. So we should see 2 replicas become available for our primary deployment, and at which stage it will start to scale down the canary back to 0. I'll just wait for that to happen. Still routing everything to the primary. There we are. So that's all done. And now, as I say, the promotion is finished. We've seen a success, and that should eventually scale down to 0. In the interest of time, we might call it there. But hopefully that's given you a nice introduction to the power of Flagger and progressive delivery. So back to you, Steve. There we go, just in time, 0.
So we're just before we finish, we've maybe got a quick minute if we overrun slightly. We have had a few Q&As come in. So let's see, we have a little look. So here's a good one. So what happens with GitOps run when there's an existing resource? So you've got I think what they're saying is you've got like a deployment defined that's already there in Git, and you then make a change locally. So which one wins?
Yeah, hi everyone. I'm James Wilson, Director of Product Management here at Weaveworks. As we're building out GitOps Run, we've gone for some simple use cases right now. And so one of the things that the team is working on right now is if you kind of run it against a workload where it already exists, such as a deployment or something like that, we're creating a low friction way for us to add that customization for you as a file into your file path, so you can easily adopt Flux with a much lower friction way. But let's say you're already running a, you already have the Helm chart or customization overlay running in your cluster. So this is kind of the next phase of what the team is working on through October, and which is why this is also still a beta feature. And once it's complete, it'll help us move towards GA. We'll basically, right, we're just trying to make it very low friction for you to kind of pause that one that's sitting on the cluster currently, and you would leverage the new one that you're kind of working with. So we're automatically reading from your file system, pulling that one in. And so that one will be the one that takes precedence over any others that are sitting on the cluster at that time. And then when you go and turn GitOps Run off, right, Flux and everything will pick back up, and your cluster will be cleaned up and brought back to the state that it was in before you started GitOps Run. And at that point, you can commit your work, push it up, and once it hits the branch, those changes that you did make will reappear on the cluster via GitOps. So we kind of have this notion of a GitOps mode whenever you're not running GitOps Run, and then you're kind of bypassing that with GitOps Run temporarily. I hope that answered your question.
Yeah, that's a very good and comprehensive answer. And I think with that, we are a few minutes over. We're slightly out of time, so probably should wrap up. So yeah, if you want to know a little bit more, you want to have a look at a white paper on progressive delivery, you can type in that bit.ly URL, or if you're quick, you can scan the QR code with your phone and jump straight to it. If you want to know more about Weave GitOps in general, please visit our website. And if you want a personal demo where hopefully the demo gods smile a little more sweetly at us, then do contact Weave GitOps and we'll be very happy to arrange a demo. So with that, thank you very much for attending, and we'll see you for the next one.